volume-mole relationship, Avogadro's law. So when you're at the same temperature and pressure, so temperature and pressure is not changing, it's being held constant, then the moles in the volume are directly related. So we can say N1 divided by V1 equals N2 divided by V2. If we look at our example, ammonia is formed in industry by reacting nitrogen and hydrogen gases. How many liters of ammonia gas will be formed if we have 13.7 liters of hydrogen gas, so that is my V1, at a pressure of 93 degrees Celsius and a pressure of 40 kilopascals. So my temperature and my pressure are remaining constant. Nowhere in the problem does it say that they're changing. And because they're being held constant, we don't really care about them at all. So this is extra information. What am I looking for? How many liters of ammonia gas? So I'm looking for liters, which is a unit of volume. So I'm looking for my V2. So I can use Avogadro's law because I'm given two volumes, talking about two different gases at the same temperature and pressure. Now, how do we relate hydrogen and ammonia? We need to look at a reaction. So the first sentence of the problem is telling us the reaction. Ammonia is formed, so NH3 is my product, and it's formed by reacting nitrogen and hydrogen, which are both diatomics. So to balance it, I would need 2 nitrogens and 6 hydrogens. So if the ammonia volume is V2, then my ammonia gas would be N2. And if 13.7 liters is my V1, then hydrogen gas is my N1. So I look at the mole ratio, the coefficients. Hydrogen is 3 divided by its volume, 13.7. And that equals my ammonia, 2 as the coefficient, divided by X. And then we have to just simply cross multiply. So 27.4 moles times liters equals 3 mole X. So X equals 9.13. The moles would cancel each other, leaving us with just liters. So 9.3 liters. Now, a variation of Avogadro's law, here we are given mass of CO, and we are looking for the volume of N2. And we know that volume is measured in liters. It also says at STP, and I know that at STP, 1 mole is 22.4 liters. So I just need to set up a table. I don't need to do any fancy plugging in to a formula. But I do need a balanced reaction. So 2 nitrogens, 2 nitrogens. I need an even number of oxygens, so we're going to multiply by 2, and we're balanced. So 42.7 grams of CO. And this is going back to Unit 6 in stoichiometry. Grams on the bottom. First thing I need to do is convert it to moles. 1 mole, 12 and 16, gives us 28 as our molar mass. Then I can use my mole ratio to go from CO to N2. 2 is the coefficient in front of CO, 1 is the coefficient in front of N2. Then I can take my mole and convert it to liters by knowing that 1 mole is 22.4 liters. And then we just have to multiply and divide. So we have 17.1 liters of N2.